dava u, that is change in temperature in respect to small t time, is equal to ut, and the problem that is given to me is that u u is a function of t, we all know that. Okay, u, that is a temperature when t equal to 0, that's the start of the temperature, is equal to 20 degrees centigrade. So if you remember, this is what we call initial condition, initial value problem. This becomes the initial value problem. Because why it is called initial? Because the initial solution at one condition has been defined, and then you have to, based on that solution, you have to find the solution at certain times. Okay, we need u at t equal to 10 seconds. 0 सेकंड्स पे रीडिंग गिवन है 10 इक्वल टू 7 पे, लेकिन टाइम के अंदर जो इवॉल्व होगा टेम्परेचर, दैट इज गवर्न बाय द फॉलोइंग डिफरेंशियल इक्वेशन. सो let's see how we can handle this thing. So w w t equal to ut, and this will be equal to that part. So let's continue then using, because this is initial variable problem with initial condition is defined, so I'm going to use the Euler's method or modified Euler's or any other methods in this case. Also there are exists other method as well for, but as far as our course is concerned, we are dealing with the three methods. Okay, so the first we are going to apply Euler's method is not mentioned, so it's up to you which method you use. Okay, Euler's method is the basic method, so I have to start from it. If you focus on this method clearly, you will understand the rest of the concept. Okay, so student, let's say, so the t, that is the time in our sense is varying like that. We are here at t0 when we have a temperature 20 degrees centigrade, and then we need temperature at t equal to 10, that is the end time. If you remember, I told you that there must be a some ending time, that at which you want to find the solution, or ending value at which you want to find the solution. And here the whatever be the temperature is not known to us. That's the main target, and we cannot go in a one step. Also the method has no problem with it, but I already told you in our method the accuracy could be obtained if we go from starting time to ending time in small steps rather than going directly by jumping from the starting to ending. Okay, so what we do, we divide this domain into a small pieces. It's up to us, smaller the piece better the answer. Okay, but then it will increase your time as well. So just for us, just to save a time, I'm giving you a simple strategy here. Simple strategy to go through this problem is that, uh, let's say, let's have let's have two intervals. This is what you have to divide yourself. If not, then it is given to you. Let's have two intervals. Okay, so if I want to have two intervals, then this means that two intervals, so there will be a point inside. So I have to go from time t0 to that time, and then from there I have to go to the other end time as well at t equal to 10, which is the time that I need a solution. Okay, so two intervals, so n here we are setting equal to 2, which means that I have to find h is the width of the interval. If you remember, that would be equal to, in this case, 10, that is the ending time, minus the starting time, that is 0, divided by number of intervals. So answer would be 5 seconds. Okay, so h would be in this case is of 5 seconds. So this gap is of 5 seconds, which makes sense. This is h, and similarly this gap is also 5, so this is h length. Okay, so what we did, we divide the interval into two. So someone can ask, why two, why not three? You can divide in three as well, then you will get two more points in between. So smaller the point, larger the point, that is smaller the h, you will get much better accuracy. But when I divide more points, then I have to go through step by step to each point. This will take longer time to reach to the end, but you will get the accurate solution. So this is what we have so far understand in our classes, that when we want to enhance the accuracy in our solution, we need to perform extra calculation. That is what the constraint we are having so far. Okay, so how to handle this thing, or how what was the process to resolve this thing? It depends on the further strategy, like uh, how to further solve. So we have this. So if you remember the Euler's scheme, the Euler's scheme is defined like that. In terms of y, we all know, but here the unknown variable is u, so it will be written like that: u I plus 1 equal to u I, that is the previous time, plus h times of whatever the function given to you. Here the function is depending on t and u. Okay, so this is the function. For I, in this case, this value will be treated as the first value. So we call this value as a t naught as well, and this value is called t1, whose coordinate is 5 second, and this value is t2 if we label them. So t naught, the first value, t1 is the intermediate value because we decided to have two intervals, so there must be a one point inside, and then t2 equal to 10 second, which is the ending time at which we need a temperature. So let's say it like that: t naught is 0 second, and the temperature we have already given is 20 degrees, so let's call it u naught. T naught u naught. Similarly, T1 is the time at 5 seconds, and the temperature at that time is U1, which is not known to us because we only have a temperature initial condition at the moment. We have to find first U1, and then using U1 we will try to move to LSM. So T2 is the ending time. Problem says I need a temperature 10 seconds, so T2 will be the ending time, which is 10 seconds. Let's say the temperature which is unknown is U2. So U1 and U2 are unknown. So what will I do? I will, based on this information, first find U1 at the temperature at T1, and then using this information I will move forward 5 units of time so that I can get the temperature U2 at time equal to 10 seconds. So this is how we move in a step by step process. Okay, so UI is this. So I will not write in the terms of yi because here the variable is given to me. So in terms of variables, I can say that I will only do I will use I is 0 here, t naught, and I is 1 here. When I use I, so I know that the index will be moved in this equation from 0 to 1, because I will not, because if I put I equal to 1 here, I will get u2, u1 plus 1 u2. So u2 is the temperature at the end, is equal to u1 plus h times of function t1 and u1. So we have to just evaluate this thing. It's very simple strategy to do so. Okay, so ending time is t2, that is u2, but I will not go to that part. There, always keep in mind that the last value, the index of the last value you have to go one less than that. Okay, so it is 2, so I have to go to 1. If it is 3, then I have to go to 2 till 2. If it is 5, then I have to go till 4. Okay, indexing will be like so. This is the equation that I have to solve for these indices. That's the main crunch of this point. So if there is another rule that you can memorize. So if there are n intervals, then you have to go n minus 1 in scripts, subscripts. Okay, so 0, starting from 0 you have to go n minus 1. So if there are 2 means n minus 1, that is 2 minus 1 is 1. You have to go till 1. That's how you keep in mind. So we know h is 5, is fixed quantity, and this. So I have to write down this equation, Euler's formula, for each script, subscript. So for I equal to 0, but keep in mind that when I say I0, I was referring that I am applying the Euler scheme at T naught equal to 0 and U naught equal to 20 degrees centigrade. Okay, so let's apply then. So we will get I0, this means U1 equal to U naught plus H is 5 in our case. Now what is F T naught? U naught. Now question is, what is F? I already told you, whatever given to you In the differential equation, as a right hand side is a function. If you remember that part, let's go back. So whatever given to you in a differential equation equal to the right hand side is f of xy. So f of xy used in the Euler scheme a lot. So this means that here we have given not in xy but in ut or any other function. So this means that du over dt nothing is here. Whatever we left on the right hand side is our f of ut or f of tu. Okay. So this is the function. So I should have pointed out this earlier as well. So it's better. Also note down this also uh, f tu is u times of t if that's a function given to you. Okay, so I have to write down this equation accordingly. So this means that for I equal to 0 I have the following construction: u naught plus 5 times of f t naught. This means I have in the function f tu which is equal to ut. This is the function. I have to put in a place of u naught and in place of t naught. So this will be u naught t naught. Okay, but what are u naught t naught? This is given to you now. On I had t naught is 0, u naught is 20. So you will get u1 directly. So u naught is 20. There is no need to write centigrade or this is a numerical calculation. 5 times of u naught. So what is u naught here? U naught is 20. But the interesting part is t naught is 0. So t naught is 0. This means you will get 0 there. Okay, so the final answer is still 20 degrees centigrade. But at what temperature? This is at T1 equal to 5 seconds. This is the temperature at 5 seconds. So what I did, I used these data to obtain the solution at this point, intermediate point, because of two intervals. So T1, the solution that I get U1 belongs to the time T1. So at time T1, this will be this, but this is not the final solution. I need solution at 10 seconds. Now what I will do, I will discard this data and I will use this data using Euler scheme again to predict the solution at U2. This is how the Euler's method works. That's called step-by-step calculation. You cannot go directly. So this is the temperature. The temperature in this case is also the same as of the initial temperature. This is also possible. Okay, just a moment. Let me do some calculation. Okay, so similarly for I equal to 1. Now for I equal to 1, if I have to do, which means that I want to find the solution at Q2, because the scheme is same. This is the scheme. So now you have to put I equal to 1. So 1 plus 1, 2. U2 equal to previous solution U1. Now you are not going to use U2. Okay. Plus H. What is H in this case? The H in this case is 5. 5 will be remain the same step size. And then you have to find F T1 because I is 1. So T1 U1 and T1 and U1 are these quantity. U1 is 20 again just for a sake and T1 is 5 seconds. It's not necessarily always this happen, but this is because of the initial condition. So now you put T 20 seconds. So this is included to U1 plus 5 times of, we know that the FTU is equal to UT, which means that if I want to read this function at T1 U1, I have to put U1 into T1. So U1 T1 and U1 and T1 is given to you step by step. You cannot go directly to U2 unless until you computed all the points step by step. 5 times of 20 and T1 is 5 seconds given to you. So if you solve this whole part, so you will get certain reading. Okay, so Let me solve it. I'm also solving at the moment. So the final will be 5 into 20 into 5 plus 20. Okay. So suddenly the temperature is showing 520. Obviously, it's a dummy problem. So it does not seems to be such a in just in a 5 second temperature from 20 reach to 520 degree centigrade. But this is at t equal to t2 10 seconds. This is the solution at 10 seconds. This is what we required as well. So what we did by solving this step by step, we have managed to find the solution at 10 seconds. So if you want much more accuracy in a solution, you can take large number of intervals. For example, if someone take n equal to 4, in this case, he will have 4 intervals. So if in that case, do not need to do that. Here will be a point, there will be a point. So 4 interval, 1 interval, 2 interval, 3 interval, 4 interval. So using T naught, U naught, he will find T1, U1, and then using T1, U1, he has to find T2, U2, and then using T2, U2, he will find T3, T4, T3 and U4, U3, and then similarly T4, U4. So you always have to go to the end point where you have to ask the solution. But it's up to your hand that how many steps you want to involve. If someone involved 4 intervals, it will take longer time. If someone was 10 interval, it will take much longer time. Although all of them will be reached to the end point. End point is necessary. So this means that if you increase the point, the only thing you will do, you will predict your solution much accurate. But obviously this will increase the computation because you have to go step by step, first from there to there, then there to there, then there to there, and then there to there. So you can imagine if there are many points, then you have to go step by step with a small jumps so that you can reach to that point. And when I have to say, you have to do some calculation, or you have to go from one step to another, which means that you have to perform this calculation on each step. Okay, so this will be I mean to say not like that, like I like the calculation like this step. Okay, so this is how you do. So the answer based on the Euler method is 520 degrees centigrade. So our answer is the rod will be at the rod will be at 520 degree centigrade after 10 seconds. This is what our as per Euler method. Euler method says that as per the differential equation solution, that will be at a 520. It may be wrong or right, but we are not solving. This is our numerical solution. But we know that we have used h very large. We use h equal to 5 seconds because we just introduced two intervals. It's very large. If someone use h equal to zero point 0.5, then he has to do many calculations, but he will notice that his solution is much more realistic or better than this one. But here there is nothing to be compared, so we cannot say okay whether which is right or wrong. But keep in mind, smaller the h interval, you will get much better solution. This is how the process. So let's solve the same problem, because I'm doing two things. I'm trying to cover some application sense as well, and also introducing the methods in front of you. The Euler is very simple method like this scheme. Nothing, you just need to put the data in a sequence and you will get the solutions at different times. Keep in mind that you never compute independent variables. Okay, independent variable will be converted automatically. If this is t naught and h is 5, so the other point t1 is 5 seconds, and h is still 5, so you have to add 5 plus 5. The last point is 10. Okay, and why I end up at 10? Because it is in the question. Question says that we need a temperature at 10 seconds. So starting from 0, I have to end at 10. But how many steps, it's up to us. For example, it is not mentioned in a question, but just for us time to understand the demonstration, I will have take two intervals, but you can take 5 intervals, 10 intervals, 20 intervals, or maybe need as per the question given to you. So in that case, you have to compute accordingly here. Okay, so I just need to compute one calculation, and then using that calculation I have predicted the solution at the final time. But if someone wants to increase more points, he will get much better result, but calculation increases as well. So let's solve the same problem again, but now we want to use modified Eulers. The difference between Eulers and the modified Eulers is that here in Eulers, I just need to perform one calculation at each step. What does this mean? I just need to calculate this formula on each step. If I apply this formula on this step, I will get the solution at this step. And when I apply the same formula on this step, that is taking a data from this step, I will get the solution at this. But in modified, I have to do it in the same thing, but I have to